Hello and welcome everyone to DCC and NIT-A YouTube channel, and today we are going to solve the third problem of Codeforces round 839 division 3. So let's see the problem. So there are two terms that are given in the question, that the strictly increasing and a characteristic. So let's understand what they mean by strictly increasing and characteristic. So there is an array of size k, and it will be strictly increasing if every next element is greater than its previous element. Okay, so these are some example of some strictly increasing array like 1 3 5. It is a strictly increasing array, and these all are strictly increasing because every element is greater than its all previous element. Okay, it's not equal, it's greater than that. So it is strictly increasing. And now let's see what is characteristic. What's the meaning of characteristic? What do they mean by it? So um, characteristic would be the number of distinct elements that we can get by taking the difference of adjacent pairs. Okay, so basically it is the distinct differences. Okay, if we have an array, let's take an array like 1 3 4 7 8. So if this is the array, then what all differences we have here? So difference here will be 2, then 1, then 3, then 1. So these are all the differences in this array, and we can see the number of distinct differences. How many distinct elements are here? Like 1 2 and 3. So there are three distinct elements. So this is the characteristic number. Okay, so this is the characteristic number. So let's understand this characteristic number by distinct differences. It would be distinct differences, like it is the difference of adjacent pairs and the distinct elements that we are having after taking the difference of all the elements. It would be our characteristic number. Okay, so now next, what is given in the question? We are given two integers. This is k and n, and we need to construct an a strictly increasing array by using all numbers from 1 to n, and it should have maximum possible characteristic value. Okay, so let's see what is it saying. Like if we have k as 3 and n as 4, then let's see, it is k and it is n. So we need to construct an array of size 3, and we can use the numbers here from range 1 to 4, exactly once. Okay, and we have to construct an array. So, and what is the condition that is given here? The condition is like it should be strictly increasing. It should be strictly increasing, and it should have maximum characteristic number. Okay, these two conditions should be satisfied for this array. Like it should have maximum characteristic number as well as it should be strictly increasing. So let's try to make some examples and try some test cases. Okay, like we can put here a 1, then 2, then 3. Now let's see what is the, it is strictly increasing, first condition satisfied, and the second condition is that like it should have maximum characteristic value. Let's check for it. Now the difference here is 1, and again here difference 1. So what are the distinct elements that we are getting? It is 1. But can we get more than that? Let's try with some other examples. Like it is also given that we can use only the numbers from 1 to n. Like here n is 4, so we can use numbers 1 2 3 and 4. We cannot use 5 here. Okay, so let's take some another example. Like if we take 1 here, then a 2 here and a 4 here, then let's see, it is valid one because all these numbers are from 1 to n, and it is strictly increasing as well. And let's see how much characteristic number we are getting. What is the characteristic number? So it is, the difference is 1, then the difference is 2. Now how many distinct element here? Now distinct elements are 2, so its characteristic number will be 2. So we know that so from here we get that we need maximum characteristic element, and that we get only by taking the distinct differences. Okay, and it should be maximum the distinct differences should be more as possible. So from here you think that if we want the maximum characteristic number, then we should be having distinct differences, and we should start from one difference, then two difference, then three difference, then four difference. And let's see what happens. Like, and this is the difference values. Okay, and if we start from number 1, then it would be good, because we are having number from 1 to n, that is here from 1 to 4. Okay, so if we start from 1, then only we will get the maximum numbers. Okay, we will get advantage if we start from 1, because if I am starting from, suppose if my I have to fill 3 numbers, I am starting from 3. Okay, then what would happen? What would be the remaining elements? Total numbers I could use 1, 2, 3, 4. The first number is 3, but I know that on the next it should be greater than that 3. Okay, so I cannot use these three numbers. Now I can use the greater than 3, and it is only 4. But if I put 4 here, then there is no element here. Okay, so it would be better if I start from 1 only. Okay, so here I am going to start with 1. Okay, if I start with 1, and what is the next element that I can get? I need a next element with a difference of 1. It means 1 plus 1, that is 2. Okay, so with a difference of 1, we get a number 2. Now we need a number with a different difference. Like its difference should be, like here it is 1. Now we need a number with difference 2. Like here could be 4. Now with a, like if I have 7 here, then its difference is 3. Like if I have 11 here, then its difference is 4. Okay, so this is the series that we have to follow in every, in every question at least, because there could be multiple approaches, but if we use this approach, then we will get the maximum number of distinct differences. Okay, so let's try to take some random sample cases and try to see that can we apply this everywhere. If let's take k and n, and let's take k as 8 and n as 11. So from here what I get, that I need to fill 1 2 3 4 5 6 7 8 places, and for that I have, what all numbers I have, 1 2 3 4 5 6 7 8 9 10 and 11. These are numbers I have, and I have to make a array which is strictly increasing, as well as it should have maximum characteristic value. Okay, so I am starting with my number 1, because I know that I should start with 1. Then I will take a number with a difference of 1, that is 2. Then I can have 4, like from this series, like 7. Then from 11, then a difference with a number 5, that is 16. But can I do that? Let's see. I can put all the I can put all the elements here that are present in this series. Okay, but 16 is not present. Okay, from 1 to n it should be there. Okay, it is not present, so I cannot take this. So now let's try. Here is a difference 2, now 3, and a difference 4. Now suppose if I put 11 here, but now I have 3 more places to fill. How can I fill these all 3 places? For filling this, I need 3 more numbers. Okay, but I don't have any other number here, so I can also not put 11 here. So let's remove this. So what number could I get put here? So if I am not able to put 11 here, if I put 10, suppose I put 10, then then the difference is 3. Whatever number I am putting here, I can put a number from greater than 7, because it should be strictly increasing. That's why I have to put a number greater than 7. But as well, I cannot put 11 here, because if I put 11, there would be less numbers that we can put here. Then if I put 10 here, then it is its difference is 3. Like it is repeated, so it won't be giving me any distinct difference. And if I put 9 here, suppose if I put 9 here, then its difference would be 2. That then also it will be repeated. If I put 8 here, then its difference would be 7 and 8 is 1. That is also going to be repeated. So it doesn't matter here. Okay, so to simplify the code part, so we will take only the next element from this, because we know that whatever element we put here, it will going to be repeated. So why not take a number greater than that, only 1. So whatever one I will take, it doesn't matter, it doesn't count. So I can take 8 here, 9 here, 10 here, 11 here without thinking much, because if I put a random number, then it would be difficult to code it. So we are taking like 8, 9, 10, 11. We can any random number we can take. Like, okay, so this is a valid one. Why? Because here I have used all the numbers from 1 to 11 as well. I have filled 8 places, and it's our conditions like it should be strictly increasing. Yes, it is strictly increasing, and it should have maximum characteristic value. Yes, it is having a maximum characteristic value. What is its value? Like it's 1 1 1 1. So its characteristic value is 3, because there are 3 distinct differences. And let's try some another example. Okay, let's try take k and n. K is 9 and n is 11. A little difference, we just put k from 8 to 9, and now we have 9 places to fill. 1 2 3 4 5 6 7 8 9. Okay, so I can put 1 here, I can put 2 here, I can put 3 here, I can put 4. Okay, no, I cannot put 3 here because I need to follow the pattern that I have already created. Like this pattern which I have created, I should be using this. Okay, so next I would take 4, then 7 with a difference. Now could I take 8 here? No, that we have already seen that we cannot take 8, because if I take 8 9 10 11, then we need to fill a more index that is not present here. So I cannot take 8 here, as well as I cannot take 7 here. Why? Because if I take 7, then the corresponding series there would be less elements. So let's try to get the remaining places. What will be the remaining places? Remaining places are, if I put 7, let's assume I put 7 here, then what would be the remaining places? 1 2 3 4 5. That is 5. And what are my remaining elements? Now remaining elements are, from this is the last number that I put, and I can put 8 9 10 11, because it is strictly increasing. I have only 4 numbers, because now we need to fill 5 places and we have only 4 numbers, so it is not possible, right? So our remaining places should be less than or equal to remaining elements. So our remaining element should be more. So it is not possible here, because we have only 4 remaining elements and we have remaining places as 5. So we cannot take 7 here. So if we take here 6, then also we can see here 1 is difference 2. The difference is repeated, but it doesn't matter. So we know that difference is repeated. We will take just the next element from it, and like from the the last element that we put, then we will just increment it by 1 5 6 7 8 9 10. Okay, if we do this now, it satisfy all the condition and it is a valid one. Okay, this is the whole approach and that we need to follow. Now we need to implement it, we need to get the formulas for this remaining places and remaining elements, right? So let's try to get the formula. Okay, for this we can take this example only. Like, so till here, I suppose I assume that, yeah, I not I'm assuming it is true that I can put this 4 is a valid one. I can put 4 here. Okay, but I need to see which element should I put here. The next element that I supposed that I should put here is 7, because from the series the next element should be the previous element, that is 4, plus the difference next I want from we are incrementing the difference by 1. Next difference I want is 3, so the next element is 7. So now I have to see that can I put 7 here, can I? So for that I need to calculate the remaining places. So the remaining places is 5 here, but what is the formula to calculate it? you know the I can get the formula by, I have filled 4 places, and total number of places that I fill, like see, what is the formula for remaining places? Remaining places would be the total number of places I have, that is k size array, minus the total number of elements that I have filled, that is this I, that is if I am complete this, that is 4, that is I basically if I am iterating. Okay, I. And now what's the formula for remaining elements? What all remaining elements can I have? Like if I have total n elements I can use, and the last element that I put is 7, then I can use only 8, 9, 10, 11, that is n minus 7, that is 4. Okay, so it is n minus the next element. So this is my remaining elements. If this is true, then I can put my 7 here. Okay, but here we seen that it is not true, it is false, so we cannot put 7 here. Okay, so if it is valid, then we increment the difference by 1. Like here we put the difference as 3. Now we will check for the difference 4. It is valid. Next we are going to try with difference 4, whether it is valid or not. Okay, if it is not valid, then we just put instead of 7 we will put a 5, 6, 7 like this here. Okay, now let's try to implement it. How can we implement it? It is very simple. It will be now very easy to understand because I have already told what the formulas that we are going to use. Now implementation. Okay, so I need difference. Okay, first the difference I will take as 1. Okay, also I am starting with 1. That is I have to take my answer variable, that answer vector. Or okay, if you are if you learn Python, then you can use a list. In C++ you can use a vector. In Java you can use a array list. Okay, so for this C++, for any you can take a container basically. So first we will put 1 here, because we know that whatever we do we have to put 1 here, because from 1 we are starting. The difference, the next element we are checking for our next element, but first 1 we have to put here. So we put 1 in our answer vector. Now what all places that we need to cover? We have total k places and there are n elements. So let's run a loop for that. Like if we run a loop from I, that is basically from 2 to k. Why we are going from 2 to k? Because we have filled our first position, that is already filled. Then we just need to fill our from position from 2 to k. Okay, one position we have already filled, and now we need to check whether we can know what is the next element that we need to put, that we want to put actually. Okay, so here we can see that the next element we want to put is 2. If it is 1, the next element we want to put is 2, and with a difference 1. So let's see what is the next element. The next element would be the equal to the previous element, the last element of this answer vector. It would be 1 plus, that is plus my in the difference. What is the difference that I have to get, what you want to put? Let's write the example here only. 1, 2, 4, 7, 11 like this. 1, 2, 3, 4. So I want to put a new number here, so it would be equal to my previous number, that is my previous number is 1, and plus the difference, the new difference. So what would be the formula? That is answer back would be the last element of this answer list, and plus the difference. This would be my next element that I want to put, that is 2. Okay, now I have to check whether I can put this 2 here or not. For that I have to check the condition, this one, whether this remaining places the remaining places is smaller than remaining elements or not. Okay, so for that I can take two remaining places, two variables for that. Like remaining places, it would be equal to k minus I. It would be remaining places, we have already derived this formula. And the remaining elements, it would be n minus next. Okay, so these are my remaining elements, and Now if the condition I need to check is like remaining places, if it is smaller than or equal to remaining elements, then I just put this I just insert this element, that is next element, that I was assuming that I can put or not. So I will just put it and increment the difference by 1. Okay. Or if I am not pushing that element, then I will put the next of that. I will push answer dot back plus 1. Then at the time I will push this. Okay. So this would be the implementation, and I hope you have understood this implementation very well. And